Hello my dear students, how are you all? Welcome to Diksha Karnataka YouTube channel. I hope all of you are doing good. Bacha, I am here today to give you one short revision, your preparation for application of integrals and differential equations. Yes, they are simple chapters, not that difficult, okay? So we'll cover up everything, sir, in detail, okay? But again, it'll be a little faster. So I hope that is okay for all of you. What you can do is, if you are somebody who wants to learn any of these chapters in detail, what you can do is just go ahead and check my sessions for the chapters I've done in 3 sessions. In 3 sessions also I've done. In AY I've done in 2 sessions. Okay, you can solve these questions, bacha, and you can see the sessions from my KCET series 16 out of 16 KCET mathematics. Okay, so please go ahead and check that out. Otherwise, if you're here to complete entire revision, to solve relative questions, very relevant questions from these 2 chapters, you are at the right place. So let's solve all the questions. Let's learn the concept first. Again, as I mentioned, we'll focus our energy on the questions, on the concept here. Questions we'll solve in the later live sessions, as you already know. So let's get started with the concept for application of integrals. Bacha, not much is there in this, but still we have some things, so we'll have a look. Okay, so first we try to do what? We try to define a function. Whichever is the working variable here, in that terms we try to put the limits. For example, here the function is in terms of x, so limits will be given for x, bacha, right? From a to c, a to b actually. So as you know, AOI, application of integrals, means whatever we have learned in integration, we're going to use that over here. We're going to use the integration to understand something. And what is that called as? It's called as, bacha, area under the curve. What we learn over here is area under the curve. This is the concept that we are learning and dealing with over here. Area under the curve. Is that okay? Area under the curve is all right. Chaliye. So what we do over here, if we look very carefully, so the function is defined like this, and they have given restriction. Is this the end of the function? No, sir. We'll have the function like this some way. We'll keep going on from the right of the point B also. So function will have on both ends. But if you provide restriction from where to where? From A to B, then they're looking for the area under the curve y equal to fx between the extremities A and B will be how much, bacha? Will be this extended area. Now how do you find that? We try to integrate this small, very small rectangle is there, na? We try to integrate that from this end to this end. How do you do that? Very simple. Taking fx, okay, or simply also we can take it as simply taking y, integrating that with, tell me the variable here, x actually. How, sir? Because we have fx here, no? That's why. From where to where, bacha? From A to B. From A to B, simply same thing can be written over here. A to B, we have fx dx. Please check. Y dx or fx dx is right under the same limit A to B. Why A to B? Because, sir, the x equal to A is the extremities. Okay, one of the extremities is x equal to A, other is x equals to B. Okay, so this is very, very simple. So what we do in the AOI, we try to find the area under the curve. Again, if the function is changed in terms of y, for example, I can take let me just show you over here only. I can take a function, same thing, bacha. If I have, let's say, a case, I'll show you over here like this. This is a function. I'm trying to find the area. I can mention the extremities now in terms of y as well, right? I can write it like this and this. Y equals to, let's say, I write here k and write here c. Y equal to k to c. Y equal to k to y equal to c. How do you find this area, sir? You'll write this function f of x equals to f of y, sir. This integration, bacha, will become integral of f of y dy, and the limit will be written for the variable y from where to where? Y equal to k to y equal to c. Y equals to k to y equal to c. This is your area under the curve. Area under the curve. Is it okay? Is it all right? So please check. This is how you find the area of these things. One more thing I want to add over here. Very simple concept. Area will never be negative, sir. So whenever you have the region given below the x-axis, okay, you can see here this region is mentioned or drawn below the x-axis, means if you integrate this, you'll get a negative value. So what you do? You introduce a modulus. You introduce a modulus, sir, to negate the effect of negative area, right? Area cannot be negative. It's a quantity which is positive. Area, right? Can you say minus 5 meters square? No, bacha. It has to be a positive entity. That's why we introduce a, check here, modulus. A modulus function is introduced. Same thing written here, just with the modulus. Whenever you have this case, for example, in this particular case, please check here. This part is positive. The area mentioned above the x-axis is, bacha, simply positive. Not a problem over here. But in this case, between the limits c to b, from a to c is positive, sir. Check here. From a to c is already positive, sir. Okay, simply positive, bacha. But from b to c, sorry, from c to b, it's negative. From C to B, it's negative. So what we have to do? We have to apply the modulus. Over here, we have done for both the parts, but usually what we can do is leave this part as it is. Once we are able to figure out the graph, we can see the graph part, the reason part, then we can mention this side as positive without the modulus. But for this, after integrating, you have to, take the modulus, bacha. Take the modulus like this. Please check. Take the modulus like this. What does mod do? Changes the sign from negative to positive. Okay, this is clear, very simple. Okay, now for all of you who are here, I am very, first of all, I am very thankful to all of you for the approach, for the all of yours result that you're giving us. Okay, the love that you've given us for everything. Even for this test series, you are here, a lot of students have already enrolled into it, so thank you for all of you who have already enrolled. Now if you are somebody who's looking for a very nice end to your hard work, your years of hard work, actually 2 years, right? 2 years for a dropper, 3-year hard work to give you a right result. We are here with your KCET test series, sir. Okay, so what you can do over here is enroll right away. Don't do anything. I know it might be for certain students it might be pricey. It is priced at the value of $14.99, but I have important things to tell you about this. If you purchase this right away, you get, bacha, PU2 Success Blueprint test series for your boards. PU2, the test series will be available at only 1 rupee. Means you pay the amount of $14.99 and $14.99 and you get the Success Blueprint test series together with it. Again, you have features available here. You can check this out. 35 tests are there total, bacha. But the best part is in this test series, Abhyas KCET test series, what is there? You have first 4 tests as free. All of you can avail this right now. Go, the link for this web page is given in for this test series web page is given in the description. Go check the link out. Go ahead, purchase this, enroll for 0 rupees. Yes, you can enroll for 0 rupees. Once you do that, you get 4-part test: physics, chemistry, bio, maths. Each will have 60 questions. You get question paper, you get PDF solutions, and also you get video solutions from our side. Okay, so you can go ahead, check the session. How do you feel about the questions? Do you feel it is worth it? I'll tell you, it is completely worth it. This is the time, bacha, to not get distracted. We are here to helping student in KCET for years now. It's been almost 20 years that Diksha is here helping students in KCET. Okay, so I want you to be part of our journey. Okay, let us be part of your journey by taking enrollment in this test series. Okay, so please go ahead. You'll not be able to find, I'm telling you, it's a very good test series. We have worked so much to create this type of test series for all of you at only a price of $14.99. Okay, so what else are the features of this? 35, as I said, total of 35 tests. In that we have 4 free tests that you can check and make an informed decision that whether you should purchase or not. If you think it's okay, then you can purchase. Okay, again, the total the paid test, bacha, will be launched after your boards. I understand your boards coming up, you can't be distracted right now. So 17th of March, first paid test will be live. 17th of March, there are total 35 paid tests. First will be live on 17th of the March. Okay, which will be again full syllabus and chapter wise test. You'll know the syllabus, don't worry about that. Detailed video solutions will be there. Okay, chapter wise one shot analysis video, analysis and revision video will be there. Chapter wise insights for last 5 years for KCET papers will also be there in the features of this test series. One more thing, do one thing, for example, the test is, sir, coming from 17th March. Why would I purchase right now? I'll tell you the reason. First of all, what will happen now, as I said, a lot of students have already enrolled into it. So to maintain this test series, we'll have to require more and more workforce. Okay, a lot of people will be involved. So prices of this test series might go up. You can see it can go to 3,000 rupees. Okay, so please avail this test series right now at the price $14.99 only. Okay, as the demand increases, the prices might also increase. So please make sure that you are somebody who have enrolled today, after, not right now. First you check the free trial, 0 rupees. You can check the test series, try yourself, and then take the decision. Let's go back quickly. I know I've taken some of your time, but without wasting any other second, I'll go back to your questions. Okay, so before that, I have something to tell you. Area of region bounded by a curve and a line. What happens there, sir? Have a look. So when we have a curve, what kind of curve I'm talking about? I can talk about circles, I can talk about parabola, ellipse, all of these things. Okay, so let's see, simplest, I'll take parabola. Okay, so if I have, bacha, let's say parabola, I can take upward parabola. okay, and I have a straight line, sir, like this. Yes sir, there is a negative part over here as well. I can take bacha only positive part also. I can take sir only positive part as well. This is also okay, excuse me, this part is also okay. For the positive part, you don't have to worry about the modulus and the intervals, okay, but for negative part you have to take care of the intervals as well. So let's consider only positive part right now. I'll explain it to you how it works, then we'll go ahead. So bacha, you'll have equations known, right? For example, for this you'll have, let's say, y equals to x square is the equation, and for this bacha you have y equals to, let's say simply you have x, y equal to simply x is the equation, or I can write here bacha ax is the equation, y equal to x is the equation. What are you gonna do? Solve these two equations to get these 2 points. What is this point bacha? First of all, 0, 0. This point you have to coordinate it to solve. Let's say it's going to be x1, y1. The point I'll mention here, this is origin, this is, let's say, P. Point P coordinate is x1, y1. What are you gonna do? I'll tell you. So if I zoom in over here, this is nothing but like this, no? You have a straight line, okay, and you have a curve like this, okay? Not exactly, I can make the change. Curve like this. I'll show you the curve. 1 second. The curve will be like this, sir. Okay, better now? Alright, so what are you gonna do? Take this, okay, and from the total triangle area, you can see from the area under the what do you call your line, so area under the line minus area under the curve bacha. On the curve, which curve is that? Parabola, okay, parabola. So what are you gonna do? You're gonna find the area under this curve, this line, straight line, and subtract from there area under the parabola. You're gonna get what? The required area. You're gonna get what? The required area, which is going to be this required area. I have highlighted over here. So how do you solve it? So you'll integrate bacha, you'll integrate ax, okay, you'll integrate ax from where to where, sir? From 0 to x1. From 0 to x1 minus, again you'll have a dx of course, then you'll have a minus sign. 1 second. You'll have a minus sign. Integrate where? From where to where bacha? Again 0 to x1. What is the function now? X square, sir, with dx. So from the area under the straight line, you take out area under the parabola and you get required area. This is same bacha when you are considering, this is going to be a required area, okay? When you take circle also, same concept is there. Circle is like this, you have a curve like this. You want to find this area. This is simple, no, in this case, okay? You have to take it like this into the account. From here to here you have to integrate. Only another line will take, not the circle part, okay? But again, this can be taken for any of the things, okay? Let's say I want only circles, right? I want only circles, not a straight line. I want only this part. What you can do, bacha? Integrate from, let's say I take this function in terms of x only, I make the y subject. I can do that, okay? And integrate from 0 to this point, let's say it is a. So integrate this as, I'll come as this, no, I think, a square minus x square, and you integrate from 0 to a. Please check. This will be area of this region, no? Okay, please check, okay? Something like this will be there. Now we'll look at the questions, don't worry. But beforehand, I think all of this is clear to all of you. Let's move on to few things to remember over here. Knowledge hub, we are in knowledge hub now. So we talk about symmetrical curves. Why symmetrical is important, bacha? Because what happens in questions, you might have to make graphs here. Okay, even in the rough part, but we have to make the graphs to understand the problem, okay? For that you need to have this understanding. Quick things, let's look at it, all of it in 1 minute. What is there? Symmetry of the curve. Have a look. If the equation of the curve contains only even power of x, like x square, x power 4 like that, then we say it's symmetrical about, very important, symmetrical about y-axis. When it is ulta, okay, only even power of y, we say symmetrical about x-axis. You can check bacha with respect of your, what do you call, your parabola, okay? If the equation of the curve remains unchanged, where x is replaced by minus x and y replaced by minus y, then the curve is symmetrical about opposite quadrant, bacha, means first and third and second and fourth. First and third and first and third and second and fourth. When you change x to minus x and y to minus y, it remains unaltered, unchanged actually. What will happen? Symmetric about what, bacha? Opposite quadrants, okay? The last one, if the equation of the curve remains unchanged, where x and y are interchanged, means when you take x as y or y as x, it remains unchanged. It means, bacha, what? It will be symmetrical about this line, symmetrical about this line, na sir, y equal to x line. Clear? Okay? Few things to remember. Please go through it. I'm gonna erase these points. Okay? just don't want to, not relevant those markings. Please go ahead and check this out. I want you to have this PDF. How can you download it? You have to go to the WhatsApp channel and download the sessions PDF from there. Okay, so any session which is conducted on our platform, you'll have to you can get just access. All the PDFs will be available for free in the WhatsApp channel. So please go ahead and have it. Okay, the revision of your AOI. Please check question number 1 now. I was waiting for it. When will this come? Let's solve the first question. What is there? Find the area of the quadrilateral formed by the lines. So very simple question. The first one I've taken. Very simple question. Chaliye, we'll take the coordinate plane first. As I said, we'll need a rough sketch, okay? In AOI, whether you draw it or not in your mind, also if you can draw, very good, but you'll need a rough sketch, bacha, okay? So if you can draw it, just draw it. It will not take much effort. Y equal to 2x plus 3. This line, bacha, will be like this, no? Y equal to 2x plus 3 will be like this. Agreed? I can draw better, actually. Have a look. I can draw a little bit better. Not a lot, but yeah. This point is 3. Correct, no? If you take x as 0, y is coming as 3. Take y 0 is coming as minus 3 by 2. Okay, this point is minus 3 by 2. Of course, yeah, y 0 means minus 3 by 2 comma 0. Here, sir, 0 comma 3. Not a problem. This is the first line, y equal to 2x plus 3. Y equal to 0 is there, which is the x-axis. This is the y equal to 0 line. Okay, what else we have? X equals to 2, sir. Okay, x equal to 2 is over here, bacha. X equals to 2 is over here. X equals to 4, sir. Like this. What are they asking? Area of quadrilateral formed by this, no? This is the quadrilateral over here. Please check. This is the quadrilateral formed. Okay, this is the quadrilateral formed. How can you solve it? How can you solve it? Area under this curve between 2 and 4. Very simple. So integrate this, sir. Your required area will become what, sir? Integration of 2x plus 3. Which what variable? Of course, dx. From where to where? From 2 to 4. From 2 to 4. Okay, please check. From 2 to 4. What I'm getting? Integrate this. I get here 2x square by 2 plus 3x from where to where? From 2 to 4. What I have? 2 and 2 is cancelled. X square plus 3x from 2 to 4. Right? Put here for 4, bacha, we get 16 plus 12. Okay? 4 square is 16, 4 into 3 is 12, minus lower limit 2 square is 4 and 2 3s are 6. What I'm getting now, please check. 28 minus 10, answer is 18. It's the area, so square units. Any option like this, please check. Option is B, sir. Have a look. Very simple question, very simple approach. Okay, between this, under this curve, what is the area? Between the constraint 2 to 4 for x. Let's move on to question number 2. Do we have question number 2 here? Yes. The area of the region bounded between the line x to 2 and the parabola. Okay, all right. Parabola y square, bacha, symmetric about x-axis. This is the curve, right? Not perfect, but please accept it. We have a line x equal to 2. X equal to 2 is this line. Okay, great. So we have to find both the areas, no? But we can take one part and then multiply that with 2. I can take only this part as A and multiply that with 2 to get our result. So our required area actually will be, our required area will be 2 times of A, okay? So let's find A first. So integrate this function from where to where? From 0 to this point. Let's call this point to be P. What is the x coordinate? 2 here. What is the y coordinate? We'll find that. We'll find that, okay? But I think x is good enough. We don't have to find the y, right? We don't have to find the y coordinate. Chaliye. What is the function given as? Y square equals to 8x. So y equals to root 8 of x. So basically 2 root 2 root x. 2 root 2 root x. Okay? 2 root 2 and root x is there, of course. This is the value of y. Please check. This is clear. Okay. Now let's find the area quickly. Let's find the area A. So A will be written like this. Integration of, I can write the constant outside. So 2 root 2. Right here root x. dx you write. From where to where, bacha? From 0 to 2. From 0 to 2. Please check now. What I'm getting? 2 root 2 is constant outside. Integration of this, bacha, will become x power 3 by 2 divided by 3 by 2. From where to where? 0 to 2. Okay. So what I have so far is 2 root 2 what will this become? I can take the constant outside, 1 upon 3 by 2, okay, taking this 1 by 3 by 2 outside, it will become, sir, 2 power 3 by 2 upper limit minus simply 0, this is 0, okay. When you put excess 2, it will become 2 power 3 by 2, when you put excess 0, it will become simply 0, okay. I have taken 3 by 2 outside, so this whole thing will become, have a look, so this a will become 2 root 2, this 2 will go up, right, okay. So I'll have into 2 by 3, okay, into 2 by 3, and we'll have bacha again 2 root 2, correct na? 2 power 3 by 2 is 2 root 2 only, right? So what I'm getting now, 2 into 2 is 4, into 2 bacha will become 8, into 2 is 16 again. Check this out, 2 into 2 is 4, into 2 is 8, and root 2 into root 2 will be 2 again, so 16 by 3 square units. So what is the required area, bacha? This times of 2, right? So my required area will turn out to be 2 times of A, so 32 by 3 square units. Option like that? Option B is correct. Please have a look. This is correct. Okay, works. B is good. All right, sir. Now let's move on to next part. Question number 2 is done, sir. I hope this is clear. Let's move on. So now we have, sir, look at differential equations. AOI part is done. That much, sir? Yes, that much. We'll solve more questions. Don't worry about it. We'll solve more questions in the practice session, the live session. Today we wanted to discuss everything in very brief way. So we have spent a little time, but yes, we have covered everything. If I missed something, let me know in the comment section. I'll try to cover up that as well in next session. Okay. So differential equations, what is there? Please check. Differential equation, bacha. We try to, whenever you get a polynomial equations in terms of derivative, this is a statement, bacha. Polynomial equations in terms of only derivative, nothing else, in terms of derivative, okay, that is called as differential equation. For example, I can write here d square y upon dx square minus x dy by dx equals to 0. Differential equation. This is a differential equation of order. What is order, bacha, here? Your order will be the highest value of the derivative. Highest value of the derivative. Highest derivative, bacha, is called your order. So in this case, you'll have this as 2, sir. Please check. We have second derivative, no? That's why it's called as 2. Order of this given equation is 2. What about degree, bacha? What about degree, sir? For degree you will have what do you call highest derivative, the power. This thing, power of, I'll repeat again, power of highest derivative. What's the power of highest derivative over here? Nothing, sir. So 1. What's the degree then? 1. One more thing, if you have an equation like this, let's say d square y upon dx square plus sin x dy by dx equal to 0. Then for this equation we can write the order. As 2. What about degree, bacha? Degree will be undefined. Understand this? For degree to exist, the given differential equation has to be only in the polynomial forms of derivative. I'll repeat myself. For the degree to be defined, the given differential equation has to be only in the forms of polynomial of derivative. Is that clear? Some basic understanding of differential equation is okay. This is the basic, very, very basic of differential equation. Let's move on to the next part. Okay, we'll talk about everything. We'll talk about the homogeneous differential equation. We'll talk about LDE. We'll talk about the methods to solve. Okay, all of that will be there. Please check. Now, same thing I've written over here in the knowledge hub. What is there? Order, sir. Order of differential equation is the order of highest order derivative. Okay, of the dependent variable with respect to independent variable. Basically, what's a dependent is what, bacha? Sometimes we write it this as dy by dx. This is y is dependent, x is independent. Okay, same, so degree of the differential equation is the degree or power of the highest order. Same thing I said, highest order ka power. Highest order's power is called as degree. In this case we had 1. Have a look. Clear, right? Not much is there. I've just given you information I don't want to miss, because at times what happens, they'll give you a very complex equation and they simply ask you degree on order. Simplify that and get the result. 1 mark for free. Okay, What is that general solution, bacha? So again, we are supposed to solve differential equations, right? It's an equation. You have to solve it. So we have two types of solutions, bacha. One is called as general solution. Second is called as particular solution. First thing is general solution. Second is particular solutions. As the name suggests, whenever you have a generic value, for example, like this. What is this called as? General solution, sir. This is called as general solution, sir. Whenever you don't have any value of a and b can be any arbitrary constant. Okay, for that reason we can say those type of solutions. Achha, first of all, this is your differential equation, okay, and this is your solution. Yes sir, this is a differential equation, this is a solution, not ulta. This is the differential equation, this is a solution. When you get that, if you don't have any constants available, that becomes your particular solutions. How do you find that? Whenever they give you in the question x and y values, they give you any points coordinate x and y for the given curve, and you use that to find the missing variables like a, b, c, whatever is there. That becomes your particular, as the name suggests, particular solution. Means only it's a fixed solution. Okay, so have a look. We have in this case 3 cos x minus 2 sin x. What is it, bacha? It's called as particular solution for the given differential equation. Please check. Okay, let's solve this question and get it done. So we have to show that y equal to cx plus a by c solution of the differential equation. Do one thing now, solve this one. Okay, just simply we'll take this and find the derivative. We'll find the differential equation for this. We'll find the differential equation for this. How do you do that? Finding derivative. Do it on this side. We get dy by dx equals to what this will be? C. This will be 0. A by c is a constant, bacha. A by c is a constant. 0, and this will become simply c because x will be 1, right? For x will be 1. Okay, so what I'm getting? I'm getting c equals to dy by dx. Now if you substitute back this thing in this equation, we get the same result. Have a look. Y equals to dy by dx, okay, times of x plus a upon dy by dx. Correct, na? C value, right? C value is dy by dx. So replace c by this thing. This is same as this. Have a look. Very simple. Moving on now. Find the differential equation whose solution are given in the following question. Okay. They have given here, sir, to us. C, okay. 1 second. Not equal to c plus 4yx is given, right? C plus 4yx equals to 0 is given. Let's do one thing. Bring the c on this side. So we get here 4yx equals to minus c. Differentiate now. It's a constant, it will become 0. Differentiate now. So we'll have 4 outside. Differentiate y. So dy by dx. Keep x as it is. Okay. We are using what, bacha? Product rule we are using. Okay. Now this time we'll keep y as it is and differentiate x. We'll have only 1 left. This will be 0, sir. This 4 can go on this side. Become 0 only. What I have? dy by dx can be written as simply y1. X is there. So right here xy1 plus y equals to 0. xy1 plus y equal to 0. xy1 plus y equal to 0. Option B is correct. xy1 plus y equal to 0. Option B is correct. Please check. Option B is correct. Let me know if you're getting a different answer. Alright. So now let's move on. Methods of solving first degree differential equations. Okay, means yes, we don't have second order differential equations to solve in this year as well. Okay, but right now, yes, if you go in higher studies, you take up second derivative also, you integrate that second time and get the result. For this year we don't have that. So let's solve. So we have to look at the methods first. So first method you've already learned, right? This is just an introduction to that. Again, what will that be, sir? Very simple. Simplest of all, variable separable method. Variable separable method. What we do in this? So what we do is we take all the like variables on one side, basically dx and x we keep on one side, and dy and y terms we keep on one side, provided that try to keep dx in the numerator and dy in the numerator again, and then whatever the term is, whether it is in the denominator or in the numerator, over here as well same thing, you integrate on the both side to get the result and use the respective formula of integration to get the desired result. Okay, so this is the method. What we do, separate the variables, all the x terms on one side, all the y terms on one side, and integrate it individually, okay, on both sides. Got it? So this is your method. Second method which we have, where we use substitution. Okay, y equal to x vx or v equals to y by x. We use that. Okay, this integration we use, where we use a homogeneous differential equation. Homogeneous differential equation. I have taken some questions on this as well. I'll explain it to you in the class only, don't worry. So in this case what we do is we separate this. I will give you the steps also in that, involved in that, how to solve that. So we have to introduce this first, then change the dy by dx. We have to change this dy by dx to terms of dv by dx by using substitution. Again we have to integrate it using the method of variable separable and get the result in terms of y and x only. I'll repeat my steps. So first thing is assumption v equals to vy by x, okay, and then what we do is we differentiate this, okay, this relation to get dv by dx, and then replace in the given expression, in the given differential equation that is given to you as a problem statement, you replace dy by dx by dv by dx, whatever it is, okay. So put the dy by dx in terms of this from this differentiation, and then you integrate using the method of variable separable method, okay, and then at last wherever you have v, replace that by y by x, okay, because the answer has to be given in the terms of the variable the question has been assigned to, okay. The last one, bacha, is very important question, is coming from this topic for sure, going to be LDE, linear differential equation again, okay. So you have both the forms here, dy by dx form is there, okay, where the answer comes in terms of y times of if. Remember this, I'll tell you all of this in detail, don't worry, coming slides. Another form is there, bacha, dx by dy. In this case the answer comes in terms of x times of if, like that, okay. We have the condition. We'll talk about what is if, sir. If is going to be integrating factor. I'm not giving you more details over here, I'll talk about this in the coming slide. Right now understand this, the final answer will come in terms of y into if equals to something, and over here you'll have x into if equal to something will be there. Got it? Got my point, right? Three methods we are using this here: variable separable, homogeneous differential equation using the substitution, and we have LDE, okay. Let's solve, excuse me, one question on the variable separable. How do you solve this, sir? Okay, even though it's a variable separable, we have to use substitution over here. You'll see how. Do one thing, right here, dy by dx, excuse me, equals to 1 upon x plus y the whole square. Right now, no, it looks very messy, don't you think? You have x square, y square and 2xy term. How will you differentiate it and not take the variable separable method easily? So what you can do is make a substitution. Whenever things are very difficult, actually most of the time substitution helps, bacha. So take here xy as v, xy as v. Now differentiate it. You will get dv by dx, okay. Why differentiating, bacha? Because you have to replace this value by this whole thing by dv by dx, okay. We have 1 over here, we have dy by dx, okay. So we can simply see that I can replace this value by, so dy by dx will become simply dv by dx minus 1. Agreed, right? Just taking this one on this side. All right, now let's make the substitutions of this and this for v and for dv by for dy by dx, for v and dy by dx in the given differential equation. That is okay. Let me have a look over here. What can I do? 1 second. This will become, sir, the same thing will be written over here. So dv by dx minus 1 equals to 1 upon v square. That's right, okay. Let's do one thing, bring this one on this side, will become positive. So I'll have dv by dx equals to 1 plus 1 upon v square. If you take LCM, it will turn out to be dv by dx equals to v square plus 1 by v square, okay. And now I'm going to use the variable separable approach. What I'm going to use, separate the variables. So keeping the you can see here dv is in the numerator over here, so no change is required. Just bring this on this side. So what we'll have, v square times of dv upon v square plus 1. This side will have simply dx. So dv and dx has to be in the numerator to have the integration possible. Integrate now, okay. This is simply x, not a problem over there. What about this, sir? I cannot integrate right now, but I can make this change. Look at this, v square plus 1 minus 1 divided by v square plus 1 dv, and this is simply this only, no problem, dx, no. So what I've done here, added 1 and removed 1. Will make no change to the numerator, it will remain as it is as v square. So we have done this to make our life easier. What is that? Divide, bacha, for this, divide this by this and this by this, okay. So what I get, integration of v square plus 1 by v square plus 1 will have dv of course minus integration of 1 upon v square plus 1 dv will have, integration of dx is already there. This is cancelling. We have only dv integration coming as v. Over here I'll have tan inverse of v. Excuse me, tan inverse of v. Formula is there, bacha, 1 upon 1 plus x square. Tan inverse of x. Over here we have v. Tan inverse of v will be equal to x plus c. Okay. What is v value? V value is x plus y. So replace everywhere v as x plus y. So x plus y minus tan inverse of x plus y equals to x plus c. X and x is cancelled, giving me the answer as y minus tan inverse of x plus y equals to c. Okay, this is your answer. Please have a look. I think this is clear, right? Please have a look. This is your answer, bacha. This is your final answer. Have a look. Okay, I hope this is visible. Alright, so very simple question. So now we have some, as I said, I explained you this thing already, but I'll explain again steps involved to solve any homogeneous differential equation. Homogeneous differential equation. What we have over here? Whenever you have a function, or basically a differential equation given like this, dy by dx is nothing but a function of x and y. What you do is substitute, bacha, y equals to vx, or simply what is this? V equals to y by x. What is this, sir? V equals to y by x. Substitute this, and then what? Differentiate this as dy by dx equals to v plus dx dv by dx, and in this function replace dy by dx by this whole thing, and f of x by y, wherever it is, just replace y by vx. I'll repeat myself. In this given differential equation, okay, that we have over here, no, dy by dx equals to f times of x of y, right? F of the function is of x and y. Replace this, bacha, this whole thing by this thing, v plus x dv by dx from here, and then of course whatever the function is, repeat, replace that as well. Wherever, sir, wherever you have y, replace that with vx. Okay, replace y in terms of vx. We have only two variables left now, v and x. Now you're gonna apply the approach of separable variable separable method to get the your solution of your differential equation. Okay, so integrate both sides to obtain this. What is this called as? Variable separable method, and the last one, after that replace v, the letter v, in terms of y by x, of course, right? Y equals to vx is there, it means v equals to y by x is there. So everywhere, bacha, you replace v by y by x to get the result, the answer in terms of original variables x and y. Is it clear? Okay, please have a look. Let's move on now. So what else we have? Solve the differential equation dy by dx minus y by x. I can see directly over here. I think it will work, right? V equals to y by x, or simply y equals to vx. Differentiate this, bacha. You're gonna get dy by dx. From here I'm doing differentiation, equals to, let's keep v as it is, differentiating x, no, v as it is, plus x as it is, and we get here dv by dx. This is okay. Alright, now we'll use this to substitution in the given differential equation. What we have? We have dy by dx minus y by x, okay, plus cosec y by x equals to 0 is there, right? Achha, one more thing, they are looking for what type of solution, bacha? They are given y and x values. So they are not looking for general solution, they are looking for particular solution, right? Means you have to, of course, get the general solution. In that, use the x and y value to get a value of c, the constant c, and put it back to get the final result in terms of particular solution. I hope that is okay. Chaliye. So what we can do, this will replace by this thing, v plus x dv by dx. What next, sir? We have this substitution is done in place of dy by dx. Now this is going to be what? This is going to be simply v. So right here v plus cosec, again, bacha, v will come equal to 0. Check here, this is cancelled. Do one thing, bring this on this side. So I get x dv by dx equals to minus cosec v minus cosec v. Okay, so I can just interchange now. What are we going to apply? Variable separable method, of course. So it will become, so dv by cosec v, okay, equals to minus dx by x. What is this now? Integration. Chaliye. So we'll see now how can we solve this. So if you have 1 by cosec, it will simply become sine, no? 1 by cosec is sine, right? So I can write this as integration of sine v dv is there, of course, and we have over here this side minus dx by x. Let's integrate now. It will become minus cos v, of course, it will be minus ln x, okay, and put here minus c, just for, you know, just to cancel the minus minus. Check here, we have minus sign here, we have minus sign here. If I put minus c, that is okay, right? Constant can be negative also, no? So basically I'm asking you to do this, plus of minus c. It's a constant value, can be positive or negative, doesn't matter. So basically I'm trying to do what is cancel the negative sign. This is cancelled with this, okay? So what I'm left with now is, my general solution is coming like this, cos of v equals to ln x plus c. Is this the final answer? No, sir. We have to replace in terms of y and x only, not v, okay? So it will become cos of y by x equals to ln x plus c. This is your general solution, bacha. This is your general solution. Are they asking this? No. They're asking us find the value when x is 1 and y is 0. Okay, so let's do that. X is 1, right? Y is 0. So cos of 0 by 1 equals to ln of 1 plus c. ln of 1 is, bacha, 0. Cos of 0 is 1. So I'm getting here 1 equals to c, excuse me. So my final answer will become, have a look, cos of y by x equals to ln x plus 1. Can I not write 1 as ln of the value e only? Basically log e to the base e is called as ln e, right? Correct, na? Log with the base e is called as ln, right? And we have ln e. It means it will become 1 only. So ln e will be 1, okay? So I'm going to write this as cos of y by x equals to, have a look, ln x plus ln e. ln x plus ln e. What will happen, bacha? ln of x into e. ln of x into e. Log of x into e. ln of x into e is my final answer. Please check. Alright. So this is done. Have a look. Cos of y upon x equals to ln of x into e. I hope this is okay. Yes, let's move on to question number 7. But before that, we do that, we have LD to deal with. We have learned the first approach, which is variable separable. I understand we are not doing a lot of questions on it, okay? Because this session is based upon learning the concepts more, okay? We'll do a question session, don't worry. We'll do a live where we'll talk about all the questions. But right now, we have only a concept to deal with. That's why I'm taking one question to explain you the concept actually, okay? So this is based upon your, what do you call, homogeneous differential equation, okay? Now we're going to move to your LDE, linear differential equation, okay? As I said, we have two forms. Let's see both of them one by one, okay? So we have dy by dx plus p times of y, right? P times of y, equals to q, where p and q are functions of x only. P and q are functions of x only. And the final answer, bacha, what you get is y times of if, the integrating factor, equals to integral of q times of if, of course dx will come. This is your answer, okay? One more thing, how do you find, sir, if? The if you get in this way, check this out, e power p dx, e power p dx. Is that clear? This is the form that you have, one of the form of LDE, linear differential equation, okay? Whenever you have only one power is there, dy by dx. So we are dealing with only that only. We don't have second order right now. So dy by dx we have p is a function of x, q is a function of again x. This is standard form of LDE of this order, okay? Basically when y is dependent variable, when you get if in this form, okay, and use if to write the final solution like this. Is that clear? Confusing? Don't worry, I'll take the question and solve it for you, okay? Next form, bacha, is this. Just when x is a dependent variable and y is independent, everything will remain same, will become px plus q, where p comma q will be a function of y. Everything will change, just the function will be y everywhere, okay? So if will remain as it is, okay? E power p dy will come, bacha, over here, and over here the final answer will look like this, x times of if equals to integral of q times of what we have, if of course times of dy bacha. This is going to be your final answer. This is going to be your final answer. Please check. Clear? Not difficult at all, right? Great. Let's solve the questions on this. Okay, sir, only this much concept? Yes, bacha, only this much concept. We don't have much right now for your KCET portions coming for this examination. Okay, chaliye, let's deal with the questions now. We have to complete our work very effectively. Okay, we can't take too much time. We have limited times left now. We have PU2 boards coming, everything is there. So we have to combine everything and make it an effective session for all of you. Okay, so question number 7, let's solve it. Find the general solution of the differential equation. Okay, sir. Which form is this? The first form, dy by dx is there now. But I think I'll change to dx by dy. You'll see how. Okay, don't worry. So let's do one thing. Write this whole term on this side. It'll become negative, right? So what I'm going to do is like this. I'll have 1 plus y square equals to minus x minus e power. Okay, what's this y is written over here, it should be over here actually, correct only. So e power tan inverse of y, okay, times of dy by dx of course is there. Let's do one thing, bring the dy by dx on this side, it'll become like this, have a look. It'll become 1 by y square dx by dy. I'm taking this entire thing, this part on this side, so it'll become dx by dy. Agreed? Okay, so what I have left now, it'll become some minus x plus e power tan inverse of y. This negative will become positive, right, and this plus will become negative. Not a problem there, right? You all know that already. So let's do one thing, put it in this form. So 1 plus y square. Don't make a mistake to get in this terms of variable separable method, bacha. This will not work like that. Okay, it will be very complicated this way. This will be easier. Check this out. Plus x equals to e power tan inverse of y. Okay, tan inverse of y. Now do one thing, divide everything by this whole thing, because I want everywhere this derivative's coefficient has to be 1. What is multiplied to this, bacha? Always 1. Nothing else should be there. What is multiplied to this, bacha? Always 1. You should not have anything else with the derivative. Okay, so everything is there. Whatever is here, you have to remove that. So it will become so dx by dy plus x upon dividing everything by this term, right, to make it 1 plus y square equals to e power tan inverse of y divided by 1 plus y square. Now you can tell me very quickly what is the value of p and q. So sir, this is my p value is this 1 upon 1 plus y square, and q value is this whole thing. Okay, this whole thing is q value. Correct now? As I said, whenever you have dx by dy, this p will be in the function of y and q will also be a function of y. Agreed? Okay. So what is the next step? Next step is to find the integrating factor. Is that difficult? Of course not, sir. Nothing is difficult if we know it. If we don't know it, then everything is difficult. Okay. We'll write here p dy will come. Okay. E power, what is this value? 1 upon 1 plus y square dy I have. So this will give me e power tan inverse of y. Okay, this is my if. All right, so let me write the answer on this slide. I get here x times of if, okay, equals to integration of q times of if and dy is there, bacha. Okay, so right here x times of e power tan inverse of y equals to, what is q, sir? Remember this, e power tan inverse of y upon 1 plus y square. What is if, sir? Same thing, e power tan inverse of y. What else I have? dy is there. Correct now? If you want, you can have a look again. What is the value of q, e power tan inverse of y upon 1 plus y square? If is this. I've used the same condition. Please check. This is the final answer. We'll integrate this over here separately. Let's call this to be integration I1. Okay, so this will become, so have a look, integration will be like this. I can take here tan inverse of y as t, let's say. So I'll have dt by dy equals to 1 upon 1 plus y square. So I get, bacha, dt equals to dy upon 1 plus y square. Okay, So basically what I'm trying to say here is, one second, okay, just have a look. I'm trying to say here this will become bacha dt. This part will become dt, right? dy by 1 plus y square will become dt, and it will become e power t into e power t. So this will transform into e power t into e power t dt. So integration of e power 2t dt. Okay, what is that? It will remain same divided by the constant multiplied to the power. So divided by 2, of course, plus c will come. What is my answer going to be? Same thing, have a look. X e power tan inverse of x, sorry, tan inverse of y, excuse me, and we have e power 2 times of, what is it? T value. What is t value? From here, tan inverse of y upon 2 plus c. This is your final answer, please check. Visible, right? That's your final answer. X e tan inverse of y equals to e power 2 tan inverse of y upon 2 plus c. Okay. Alright, we have after this only one question left to solve. So just take your time and go through this. This is clear. Let's move on to the last question of the day. Solve the differential equation dy by dx. Okay, dy equals to cos x times 2 minus y cosec x dx. Given, again bacha, we are looking for particular solution bacha. We are looking for particular solution only. Whenever you have x and y constants given, no? Means using that we'll find the constant value and then we'll put it back in the general solution to get the result in form of particular solution. That makes sense to you, all of you? Yes. What we have here, let's do one thing. Bring dx on this side. Okay, so it'll become dy by dx equals to, multiply this now, 2 cos x minus y. Cosec is what bacha? Cosec is 1 by sine, no? Into cos I have. Think about it. Cosec x is 1 by sine and cos is simply cos. Okay. So what I'm getting now? dy by dx equals to 2 cos x minus y cot x. Y cot x. Cos by sine is cot. Bring this term on this side to have the form of LDE in the which form? dy by dx. Y is the dependent variable. Y cot x equals to 2 cos x. Not a problem. So p is nothing but cot x and q is nothing but 2 cos x. Clear? Okay. Let's do one thing. Integrate to find the if value. So if will look like this: e power p dx, e power p dx. Correct now? So how do you solve it? So sir, if the integrating factor will turn out to be e power integral of, one second, e power integral of cot x dx, right? P is cot x, yeah. Integral of cot x dx. We know this is the answer. E power log sin x. Agreed or not? Log sin differentiation. Think about it. Log sin differentiation, what will happen? It will become 1 by sine. Correct, na? If you differentiate, if you're not sure, I hope you should be, but if you're not sure, log sin will become 1 by sine and sine will become cos. So, sorry, yeah, cos by sine will become cot only, no? That's why. Integral of this cot will be going to log of sine. I know you know this, just if somebody is not able to get this thing clicked at the moment, that's why I wanted to explain this to you. What else I have? E and log will cancel the effect. We'll get this as simply sin x. Exponential and logarithmic function, they are inverse functions, right? So we'll cancel the effect. I'll have simply sin x left here as my integrating factor. Let's write the final answer. So I'll have y times of sin x, right? Y sin x equals to integration of what you have, 2 cos x into sin x, and dx is there, of course. This is the q value and this is simply if from here. Okay, so what I'm getting now, y sin x equals to integration of 2 sin x cos x, bacha, it will become sin 2x, no? Integrate this now. So I get here y sin x, okay, equals to, think about it, minus cos 2x by 2 plus c. This is your final answer for general solution. This is the final answer for general solution. Okay, please check. This part is clear. Now, is this the answer? No, sir. We have to look for particular solution. So let's write this over here. Okay, I have not kept space for you. Let's do one thing. I can take some space on this side. All right. I can solve it over here, bacha. Let me give some space. Okay, y sin x equals to, we'll have minus cos 2x divided by 2 plus c. This is your final answer. What answer is this, bacha? Is your final answer what they are asking? No, sir. This is the final answer for your general solution. Okay, we are looking for particular solution, bacha. They have given the x and y value, so we are looking for particular solution, bacha. Okay, so how can you solve this? Let's have a look over here. So we'll write this again. Y sin x equals to minus cos 2x by 2 plus c is there. Have a look. Minus cos 2x by 2 plus c is there. So what we can do is simply put the x value. X is given as pi by 2, y is given as 2. X is given as pi by 2. 1 second. X is given as, okay, we have x equals to pi by 2, okay, and y equal to 2, correct? Y equal to 2. So this will become 2 times of what I have, sine pi by 2 equals to minus cos 2 times of pi by 2 divided by 2 plus c. What I have over here is 2 times of sine pi by 2 is 1, bacha, minus cos 2 and 2 will cancel, so cos pi plus c, of course by 2 is there. What I'm getting for this, 2 equals to minus cos pi is minus 1 by 2 plus c. What I'm getting now, 2 equals to 1 by 2 plus c. Bring this over here, I get 2 minus 1 by 2 equals to c. It means c equal to 3 by 2. Okay, now put it back in the general solution to get the result in form of particular solution. Okay, so what I have, y sin x, okay, equals to minus cos 2x by 2 and plus this value, plus 3 by 2. This is your final answer. Please check. This is your final answer. Have a look. Y sin x equals to minus cos 2x by 2 plus 3 by 2 plus 3 by 2. Have a look from here. This is clear. All of this is clear. Okay, done. All right, so this was it for your session on differential equation, and I hope you enjoyed that. Okay, I hope you had fun. We have done also a part of AOI. So let me know how you felt about the session, and I know time is less. You have a lot of things to do. If you want to talk to us, if you want to tell us something, please leave your thoughts in the comment section. We'll reply to that. Okay, just keep working hard, bacha. Time is little less, so that's what is required, and I'll see you in the next session. Till then, take care. Bye bye.